The purpose of this video is to walk through a simple demonstration of programming a two-dimensional part with some very simple geometry, very common but simple geometry. We're going to do some milling, some pocketing, some drilling, and so forth. Along with this video, there should have been a link for you to download a print of the part that I'm going to walk through. And when we're done, I'm hoping that you will have a good understanding of what it takes to program a Hurco, how simple it is, and have a good understanding of what kind of features are available. Because doing this, I'm going to go through most of the areas of the control, such as part setup, tool setup, actual part programming, graphics, file manipulation, and so forth. So it should give you a really good overview of what's available on the Hurco control. The first thing I want to do is I need to go and create a new program. I'm going to do that by going to my Program Manager screen. The Program Manager screen is where I'm going to create new, open existing, save files. If I go here to the Disk Operations menu, you can see that it is just a Windows Explorer file tree. Here I can create new directories, cut, copy, paste, basically do any kind of file manipulation that I can do on my computer, I can do under Disk Operations. This Program Manager screen, however, is just an area where we have open programs that are currently active, whether they're the program we're actually running or one that we are just getting ready to use for another job or something like that. So the first thing I want to do is I want to create a new conversational program. It's going to name it no name, whatever the next available number is. In this case, there was already a no name 1, so it created a no name 2. And at this point, I can go do a save as, or I can simply write the program and run it without ever having saved it. If this is for a fixture or something like that, I don't actually have to save the program if I don't choose to. If I wanted to, though, I could go to save as. I could go find the folder. I'm just going to save this on my desktop, and I'm going to put this as video demonstration. Click the save button, and now you can see that it has a name. It also has a path. It has been saved to my desktop, just as I told it to. So. Next thing I want to do is I want to go through and make sure the tools that I want to use for this job are set up. Here we have a library of all the tools that have ever been set up on this particular machine. Now the tools that I want to use may or may not have been set up. If they haven't, I can simply go to the tool setup screen, highlight and type in a number for the tool that I'm getting ready to describe, and then walk through the information that we have here on the screen. The 3 tools that I need, or the 4 tools that I need, I'm going to use a 1/2" end mill, a 3/8" end mill, 3/8 drill, and a 1/2" 45-degree chamfer tool. Those have already been set up. As you can see here on the first screen, tool 1 will be my 1/2" end mill. I have things like the tool type. I want to go through and select the type of tool that this particular tool is. It's an end mill in this case. Put in the diameter. The tool length will be established at the time of setup. Not necessary for programming and using the graphics, but it would be obviously if I'm going to run the machine. And the second thing I want to do after I've made sure that the tool is created and described correctly is go through and associate some speeds and feeds. The reason I do that is as I pull this tool into a program, if the speeds and feeds have been created already, it will populate the speeds and feeds fields in my program. Here I've programmed it with surface footage of 800, and based on the diameter you can tell that it calculated what the RPM will be. I've given it a chip load of 5 thousandths per flute and told it that there were 2 flutes. Therefore, it was able to calculate the inches per minute feed rate. If I wanted, I could have put a direct RPM and a direct feed rate in it would have then calculated my surface footage and my chip load. So I can program either way that I'm used to programming. If I like to program with surface footage and chip load, the manuals that I have, the experience that I have tells me to do that. That's what I do. If I know a direct RPM and a feed rate as inches per minute that I like to use, I can put those in. Either way, the control is very flexible that way. So here we have tool 1. Tool 2 will be my 3/8 end mill, and so forth. Tool 3 is my drill. And we continue to do this for all of the tools in our program. Now, because we can accurately describe the solid model that we're going to be cutting, and we'll talk about that in a minute, we need to be able to accurately describe the tools that we're using. Now, on a drill, there's a drill point. You can see that if I go to the advanced tool settings screen and I highlight an individual field, here I've done the diameter, you can see that it shows on the graphic what that field is asking for. And as I cursor down through these, it shows you exactly what that particular field is asking for. And one of the things that is not necessary but very helpful to put in would be the included angle on the tip of the drill. That way, when I'm looking at my solid model, if I have drilled a hole that needs to break through somewhere, and if I'm accurate with this information, then my graphic should show exactly what my part's going to look like. Here we can tell it how many flutes, cutting direction, but most importantly, it's going to sequentially add a color, a different color on my graphics to every tool that I use in the program. However, if I choose to force a specific tool to have a specific color, which I do often when I'm engraving, I will maybe put my face mill at a darker color and my chamfer tool or my engraving tool at a much lighter color just for contrast. I can force that if I need to. In this case, I don't care. I'm going to let it sequentially pick all my tools. So now I've gone through and I've created my program. I've set up my tools. The next thing I want to do is under Parts Setup, More, Stock Geometry. I want to go in and set up a piece of solid model, for this, piece of stock. Now I don't have to do this. As I hit Draw, the control will automatically create a piece of stock a little bit larger than whatever it is that I'm trying to cut. However, if I want to be accurate, I can go to the manual sizing. Do I want yes or no? Do I want to manually create a piece of stock? Yes, I do. And when I do that, you can see that it gives me some information and some choices. One of which is whether it's a box or a cylinder for the type of material that I'm using. In this case, it's going to be a box. You'll notice from your print it's 6 inches by 6 inches by 1 inch thick. And it's going to assume the front left corner of this part is 0. I'm going to leave that there. But if I were going to program from the center, the back left corner, or somewhere else on this part, I would then use these reference positions here to then move the stock into the correct position based on where it is that I want to program from. But again, I'm going to program from the front left corner of this part just to keep it simple. So I'll leave those at 0. Now I've gone through, done my part setup, my tool setup, and now I am ready to do my part programming. So here are the menus that I have to choose from. Any position blocks that I may want to use. Probably going to use that most often at the end of a program to bring the part out to the operator to be able to change parts, flip the part over, or what have you. I have holes menu, anything holes related, boring, drilling, reaming, or tapping will be done under there. Any milling operations, lines and arcs, or simple geometry will be done under the milling tab. Anything that I program, I can then pattern. And we have some miscellaneous features such as change part setups, adding an M code for whatever reason, whether it be for fixturing, pallet change, what have you. And then we have an NC program call where we can merge a conversational program and an NC program together. First thing I'm going to start with, if you look at the print, is I'm going to machine that frame, the 1/4 inch wide frame, all the way around the part. And that's a milling feature, so I'm going to select milling. It's a simple piece of geometry, so I'm going to select frame. If it was something other than a circle, frame, or an ellipse, I could then select the lines and arcs and create an arbitrary shape. But in this case, I'm going to select frame. And one of the things with the conversational control, if you notice as I highlight a field in the bottom left corner of the screen, it's telling me what it's asking for. Sometimes it's more descriptive than others. It depends on what it is that it's trying to create. But in this case, it wants to know the X and Y location of one of the corners of the frame. Now, the frame has 4 corners, and I can describe this location as the corner of any of the corners on this particular frame. I'm going to pick the bottom left corner, and that's going to be 0.25, 0.25. Now it's asking for the length in X and the length in Y of the frame from that corner. Well, we're going to travel 5.5 inches in the positive direction along X, and we're going to do the same thing, 5.5 inches in the positive direction in the Y. My Z start, that's the position I'm going to wrap it to above the part before I begin to do any feeding. And my Z bottom will be the final depth of this frame, which is 0.25. Corner radius, if each one of those corners had a print dimension of 3/8 of an inch or whatever, I can put that in here. I'm going to put 0.01, 10 thousandths radius, just enough to break those corners as it goes around the frame. The next is a start side. That means where am I going to blend on? Circles will generally blend at the 3 o'clock position. Frames will always blend at the 6 o'clock position. But based on the geometry that I am cutting or other features on the part, that may not be possible. So I'm able to then pick which side I want to begin. I want the tool to blend in from the bottom, the right, the top, or the left side. So I have some freedom on how that tool enters into this cut. Next, I have the corners tab. In this case, I put a 10 thousandths arc on all 4 corners. But if I wanted to control those corners independently, you can see by the image here that each corner has a number associated with it. And I can control those with either a radius or a line length and angle for a chamfer, depending on my needs. Again, I'm just going to leave these all at 10 thousandths just to break that corner. Next, I come to the type of tool, or the tool that I'm going to use. I can either type that tool number in if I wish, select it from the list. In this case, I can hit the tool field here at the top, organize everything by tool. It alphabetizes them and organizes by tool. I can then go down and find the end mill that I want, which is a 1/2 inch end mill. Or I can sort them by number. Knowing I want tool 1, select the tool here. So I have a couple different ways to do that. I highlight the tool that I want, I hit select tool. It then inserts the tool into the program. You can see that it puts the feed rate, the RPM, peck depth in this case, plunge feed. Anything that I have set up in the tool can be populated here automatically. Now, I have to pick a strategy. What kind of frame is this? If I leave it at on, that'll be the center of the tool traveling around the frame. There'll be no cutter comp whatsoever. I can do an inside or an outside frame. That means the tool is going to blend on by a parameter value, usually 3 millimeters. It'll start off with a part by 3 millimeters, blend onto the cut, create the frame, blend off that same amount. Inside and outside tangent act exactly the same way, however they do not blend. Or I can make this a pocket or a pocket island. In this case, I'm going to cut an outside pocket, or excuse me, an outside frame. If I choose, I can select the finishing tab, put in another tool here, or the same tool. The roughing tool would then leave a predetermined amount of material for finishing. for the finish tool. If I do not use a finishing tool, which is I'm going to be the case here, I'm not going to use one, then the roughing tool will take the feature to final depth. I'll go ahead and draw this. Now we see that we do have the frame that we created. Graphics, I can roll this around, view it from different angles. I can look at it in any one of these four views: top, front, right side, or isometric. I can look at it as a solid, just a wireframe, or a show all, which is a combination of the two. And you notice that everything here, toolpaths, rapids, plunges, so forth, they all have a color associated with them, and I can turn those on and off. If I go back here now, you see that the rapids have been turned on. They weren't there previously. You can see that the center line of the tool running around the part, the stock geometry would be in green, plunges would be in purple, so forth. I typically like to look at things in the solid model view. It can be transparent or opaque. Here we see it. Here we see it in transparent. I can actually see through the part a little bit. So if I had parts or things that were coming in from other sides on a multi-axis part, for example, I'd be able to see those very well. Okay, so now that we've created the frame, let's go in and do that large circle pocket. So I go to my program, hit the next block, also going to be a milling block. It's going to be a circle, and I just begin to fill out the information. The center of the circle is 3 inches and 3 inches in X and Y. The radius for that, it's a 4-inch diameter, so 2-inch radius. I'm going to start at 0.05 above. I'll go down half an inch. My final dimension of depth. My start angle, again, it's going to begin at the 3 o'clock position to blend in and off of this particular circle, but I can pick anywhere between 0 and 360 degrees. 0 is fine in this case. I'm going to leave it alone. Again, I'm going to use tool 1. I know that. I'm just going to type in the tool number. In this case, it's going to be a pocket boundary, spiraling outward from the center. I can also go from the outside towards the center, and I can use some what we call adaptive path or high-speed pocketing routines as well, whether it be a zigzag or a one-way. In this case, it's just going to be simple pocketing, outward, speeds and feeds. The tool step over percentage, our peck depth, plunge feed, all of that I've set for us. I hit the draw button, and now I have a circle in the middle of my part. Continuing to build here. For my next block, also going to be a milling circle. Same center, different radius. In this case, I'm going to wrap it to -0.4 in my Z because I already have a pocket that's a ½ inch deep. My final depth is going to be 750. Again, this time I'm going to use tool 2. Still going to be a pocket. The rest of the information that came in is fine. And now I have a separate pocket. And you can see that the tool number changed, so the color changed. Last feature that we have on the print is that bolt circle pattern. You notice that I keep going back to what is called the review screen. The review screen is a table of contents, if you will, of the blocks in your program. Some of these blocks will just be one page, as they are in the simple geometry we've programmed so far. Sometimes they will have sub-blocks that will show up in that right corner, such as lines and arcs that may be used to create a particular feature, or a holes block, which we're going to see next. Go to the next block. This time it's going to be holes. I'm only going to drill in this case. I'm not going to worry about a center drill, but if I wanted to, I'd go under my drill, select center drill, spot drill, or whatever. Here I'm just going to go right to my drill for simplicity. Rapid to point 4. I'm going to drill all the way through the part using tool 3. Now, RPM, feed rate. Here's a peck depth that I'd already put in for this particular tool. I can change it if I want. If I zero it out, the tool will go to depth without any pecks. If I put peck depth values in there, it'll stop at that particular depth and do one of two things. It will either stop for a standard peck where it rapids all the way out of the hole each time, or it'll stop just as a chip breaker and pause at that particular depth until the chips are cleared for a couple revolutions. In this case, I'm going to leave it at standard. Now from here, I would continue to build my processes. I would go to next hole operation. Maybe it's a tap. Maybe it's another drill, a center drill, then a drill. Whatever it would be, I would continue to build the processes or the what that I'm going to do. Then I'm going to tell it where. Either XY locations or a bolt circle. In this case, we're going to use bolt circle. Simply asks how many holes are in the bolt circle. 1, 2, 3, 4, 5, 6. There's only 7 holes. But that is an equally spaced 8-hole bolt circle that's being showed. So I'm going to say 8. That will give me the equal spacing that I need for the 7 holes, and we're going to end up skipping one of those holes. So I need a number of holes is 8. The center is 3 and 3. The radius in this case, it says it is a 3.5 diameter bolt circle, so 3.5 diameter divided by 2. And the start angle. Start angle is very important. Start angle tells me where hole number 1 goes. In this particular case, I can put one either at 0 degrees, which is 3 o'clock, or 90 degrees, which is 12 o'clock. I could also put one at the 6 o'clock or 9 o'clock position. I'm going to put one at the 12 o'clock position for hole 1, so I'm going to say 90 degrees. Now the reason that's important is because that's hole number 1. If I then count the holes going in the counterclockwise direction, we see hole 1 at the top, 2, 3, 4, 5 at the 6 o'clock position, 6, 7. Hole number 8 is missing. So that's the number that I put in my skip list. I skipped hole number 8. Now when I go to draw this, you see that I have a bolt circle. With the skipped hole. Now something is wrong. Doesn't look like my print. Here I can use my graphics to go to the exact block that has a problem. When we build a program, we have only a limited number of things we can call it. It's a mill circle, it's a mill frame, it's a holes block, it's a mill contour. Well, what particular feature was cut by which particular block? Well, in this case, I can go to data block search. I can highlight the feature that I want. In this case, it's going to be the hole. Jump to the block, and it takes me to that particular block and that particular feature. I'm going to go back one operation to my hole, and I see that I have a 3/8 diameter hole that I'm using the wrong tool for. The other thing about conversational programming is I can change things on the fly. I don't have to go back to a post-processor. I can just simply go to my select tool from list. I can organize by type. I can go to my drills, find the 375 hole, tool 15 in this case, select it. All my feed rates and everything still came in. Go back and draw it, and it is now repaired. Very easy to recover from something as you go. And one of the other beautiful things I like about conversational is, let's say that I want to put a chamfer on the inside of this circle and the outside of this frame. Now I could reprogram that very easily, but I can also go to my tool review screen or program review screen and pick these first 2 blocks. The mill frame outside that I want to chamfer, and the pocket circle, the largest one that I want to, in the center that I want to chamfer. I can copy those, paste them, and then simply change the depth. I'm going to go 30 thousandths deep on that frame. I'm going to go 30 thousandths deep on the mill circle. It's going to be an inside this time instead of a pocket. But I'd also need to change the tool. In this case, I'm going to use tool 13, which is a 1/2 inch chamfer mill. And I forgot to change that on the one previously, so I'm going to do that now. Now when I hit draw, you can see that we do have a chamfer now on the inside of that circle and on the edge of that frame. I didn't have to reprogram anything. Again, this was simple geometry, a frame and a circle, not that hard to recreate. However, a lines and arcs contour with lots of sub-blocks, if you will, would be much more difficult to recreate, so I can simply copy and paste that. Now here we see the program review screen. Again, this is a table of contents of the program itself. If I highlight the holes block, now you can see an example of what the sub-blocks look like. But one thing we haven't done yet, and that is, if I ran this job today, and I have to run it again 6 months from now, I may not remember what I called it, but I know what it looks like. From the graphics screen, you see we have this little snapshot button. If I hit snapshot, it'll tell me that an image was stored in the program. I now go back to my program manager. You can see in the bottom left corner an image that resembles what we just programmed. And I can also, under program properties, I can put some information here that will appear in this text window in the center of the screen. So, based on what I've named the program, where I have saved it, what the cutter path is, or excuse me, the file path, what the part looked like in this description I can put here in this text box, I should be able to accurately describe whatever part it is that I want to program. Be able to easily find that later on. One last thing that I would like to talk about, if I go here into any one of these blocks, we can easily change from metric to inch. The bottom of the screen, you can't see it here, I'm going to pull this up so you'll be able to see it. The bottom of your screen on the machine itself or on your desktop software, which is what I'm using here, we can simply touch the word inch in this case, and it's going to pop up a menu that says, do you want to switch to the metric units? Yes, I do. If I select yes, you'll notice that all of my coordinates in the program, my tooling information for this tool number 1 was a 1/2 inch end mill. It's now a 12.7 millimeter. All of my parameters, my digital readout, everything literally switched to millimeters. So I could program off a metric print without having to convert anything. And when I'm done, I simply go back to inch or imperial units. Everything switched back, and I'm able to then program back in inch again. Very good way to program off a metric print if you're not used to it, and then switch to inch numbers, which is something that, in my case, means something more to me, and it's better for me to run in inch than in metric.